All right, guys, this is going to be the first video we're going to do for 10.3. And the main idea for this, you can look at the objective, is when we add or subtract radicals. Take that down where it has in the red combine like radicals. This really is going to be the same concept of when we combine like terms. You know, the basic fact of you can only add x's together. You can't add x's and y's. Let me show you a quick example before I get to the three problems that I circled. Here's a quick example. Alright, let's say I have the square root of 2 plus the square root of 2. These are like radicals because I have the same number in it. Now there's no number on the outside of the radical, so it's assumed to be 1. So it's 1 root 2 plus 1 root 2. So what you're going to do is you add these up. These are kind of like your coefficients. So 1 plus this 1 gives us 2, so this equals 2 root 2. Kind of like if you had x plus x, that equals 2x. Same thing here. So we kind of treat the radical like a variable. I'm going to show you a common mistake. If you had root 2 plus root 3, we cannot add these. These are not like radicals because I have different numbers inside the square root. Common mistake is to look at this and say, oh, this is the square root of 5. But you can't add numbers inside the square root. You can multiply numbers in the square root, but you can't add. So you can't do that right there. All right, let's look at other examples. So I can only add the radicals that have the same number inside the square root. All right, let's look at number 1. Okay, let's kind of zoom in. So number 1, if I look, I have two terms, and they're like radicals. I have the same number in the square root. I have this square root of 3, that square root of 3. Now remember, the first square root of 3, that's like saying there's a 1 on the outside. So what we do is we add the numbers on the outside. So I add 1 and this 2, which gives me 3, and then I keep the same number inside the square root, so it's 3 root 3. And I know that square root of 3, I can't simplify that any further, so that's my answer. Okay, if I look at 2, now I have 3 terms, and I want to identify the like radicals. Well, the like radicals I have here are square root of 7 and this 3 root 7. So remember, the square root of 7 is like saying 1. So this 1 plus this 3 gives me 4. And then I just bring down the root 7. So I'm going to cross this out. I'm done with the root 7s. And then the root 2, I just bring that down. So it's plus root 2. And I'm done because 7 and 2, I can't add these together because they're not like radicals. So that's our answer right there. Okay, let's move over. Let's do one more. Okay, now number 3, we have 4 terms. So all 4 terms have a radical. So let's pick out the pairs where we have the same number in the square root. So we have 15 root 3. I'm going to look for another root 3, which is the last one, negative 11 root 3. So I look at the 15 minus the 11. 15 minus 11 is 4. And then I just bring down the root 3. So I'm done with the root 3's. All right, so then you look, we have 2 terms left, and they both have a square root of 5 in it. So I can combine these. These are like radicals. So I have negative 14 plus 6. Right? That's the only math you're doing. So negative 14 plus 6 is negative 8, and then just bring down the root 5. So then we're done with that. Yeah, I know that I'm done because square root of 3 and square root of 5, that does not simplify any further. And I can't subtract those because they are not like radicals. So that's our answer. So main idea there, objective, you can only add the numbers on the outside of a square root if you have like radicals.